Epic. Epic! Epic Stat Tool 1 speedruns of statistics! Brian Stevens versus Chapter 16, more on tests and intervals. Begin!
Hey everybody, we are back for another speedrun. Say hey if you are in the chat. Woo! Oh my. Fast speedruns. I thought 30 minutes would be enough, but whew, lot to cover. Once again, please check out the other videos if you haven't. We got some other videos going over these more in depth. I've got full chapter reviews. These are meant to be quick, so if I don't go into enough detail, please check out the full chapter review or the individual videos I have going over each test. But this is meant to be like a speed run. They're like cliff notes, as the warning says at the start. So don't expect to learn everything, but expect to find areas that you might be like, ooh, I need to cover that more. I have no idea what Brian's talking about there. So make sure to check out the other videos. Okay, let's go ahead and grab some of this and start talking. I feel better about this chapter. I feel like 30 minutes is going to be more than enough for this chapter. I feel good about this chapter. I think that's everything. We could almost, you know what? I think we can get it all, yeah, because like it ends with power. Let's go and grab all of this right here. Say hey if you are in the chat. Let's reboot MuBot, and let's start the speed run. There we go. We've got everything. And let's go ahead and reboot MuBot. MuBot's going to crash the world as he usually does. And he's waking up. And the world is back. Okay, so speed run ready to go. I might just start another clock by accident. Okay, here we go. Interpretations of a p-value in general. So we've talked about this a lot in these videos so far. A p-value is the probability of our results or results more extreme happening by random chance variation, given that the null is true. What do we mean by that? What does that all mean? Because that's a lot to think about. When we talk about a p-value, once again, we have to assume the null is true. That's a huge thing for the p-value. So the p-value has the assumptions that the null is true. So the null is at the center of the curve. So the most likely thing to see if the null is true is the null. Just think of this as a dartboard where darts land closer, or the distribution of where the darts land is shown right here, where most darts are going to land towards the center. Now when we think about our results we're going to put here as a red dot. So what we're going to then do is talk about our result right here. So this is where we landed. We landed right here. There's our results. So then we'd ask, what is the probability of our result or a result more extreme? And the way we know how to shade is the sign of the alternative. Check out the last video to know how to shade which side. So we're going to say, what is the probability of our result or a result more extreme occurring by random chance, because any of these things could occur, given the null is true. So the probability of our result that we observe right here occurring by random chance variation, any of these dots that could appear, given the null is true. So once again, when you put this all together, it's the probability of our results or results more extreme occurring by random chance variation, given that the null is true. And this one seems slightly unlikely. We could put here a p-value for it, which is going to be the amount of the curve shaded. And it might be something like 0.04, which using an alpha, which is our rejection criteria of 0.05, we could reject the null. If that's the p-value right there, we would say, well, that p-value is lower than alpha. We reject the null. So remember, when the p-value is low, reject the null. When the p-value is high, just let it fly. So that's what a p-value is right there. It tells us the conditional probability, the given part of it, the conditional probability of our results or a result more extreme occurring by random chance variation, given the null is true. When it's low, we reject the null and we say, that doesn't look that likely. And when it's high, we say, you know, that's quite probable. We could move our result over, and then we would have a much more likely result. So we'll move that little red dot over. So if we were to have, can I increase this enough to do it? Yeah, it's probably not going to look great. Ooh, that's not horrible. There we go. And then the dot, I'm going to have to do this. There we go. Look at that. There's our result. And there's the probability of a result as extreme or more extreme than our results occurring by random chance variation, given the null is true. And now the p-value would increase because this is a more likely result. This result right here might be something like 40%. And that would mean 40% of the time something as extreme or more extreme than our result would occur by random chance variation, given the null is true. So I'd say, I think the null is plausible right here. I think the null hypothesis is quite plausible. I believe it. I don't reject it. I fail to reject it. So there we go. A sufficiently small p-value could mean that our results were very unlikely, that the null hypothesis is true, and there's very... And all this right here is just going over the interpretation that we've talked about in just a moment ago. Alpha level, this is huge. We should know immediately what alpha is. Alpha is going to be the following symbol, and alpha can be declared for any problem. Alpha is the probability of a type 1 error. We're going to get more into that in just a moment right here, but alpha is going to tell us when we reject the null. So you have to be very careful because we could say in a problem, use an alpha of 0.10, and maybe you get a p-value here. Let's say you get a p-value equal to, and let's write p-value next to that so it doesn't look like proportion. P-value equal to something like this right here. Now, in many instances, we would not reject the null here because classically alpha is 0.05 unless stated otherwise. So we've got over here what alpha usually is. By default, alpha is this. Like if we don't say anything, assume 0.05. That's classic statistics. That's what most statisticians do. But you can declare your alpha. You're just saying, I want to reject at 0.10. And that's what we're saying. I want to reject below this value. So when we have p-values lower than alpha, p-value of this, we can reject. So this 0.08 can be rejected at the 0.10 alpha level, but cannot be rejected at the 0.05. So increasing alpha makes it easier to reject. We're going to see issues with that here in a moment. Practical versus statistical significance is basically statistical is the alpha level. All we're doing when we say something is statistically significant is we're saying low p-value. That's the easy one right there. We're just saying low p-value. This is not statistically significant at the 0.05 level, but this is statistically significant at the 0.10 level. So this would be statistically significant at the 0.10 level because it's below alpha, i.e. statistical significance just means we reject the null, the p-value is below alpha. But the hard one to do right here is the practical significance. Practical significance, well, one, you need statistical significance to get practical significance. So you have to have statistical to have practical because it has to be unlikely by random chance. But the practical significance is the literal, do I care about it? So if I told you that going to a seminar could increase your salary, and we have evidence of this, like good evidence, it's unlikely by random chance, your salary when you graduate UT by $10,000, like the average student who goes to this seminar increases their salary by $10,000 when they graduate. Would you go to this seminar? Maybe it's like a 2-hour seminar at night. It's just one night. And we say the average student who goes to this seminar increases their salary by $10,000. You'd be like, yeah. I mean, I'd say that. I'd say, yeah, that sounds really awesome. I'd love to go to this seminar that's going to somehow help me, maybe negotiate salaries. Maybe it's a seminar on negotiating salaries. And we say, well, there's evidence to show that people who go to this seminar have on average a higher salary by $10,000. And all you're saying when you say it's practically significant is you're just saying, I care about this. And that's super important in the business world. Like, do we actually care about the results you found? And that's what practical significance is. It's the question of, do I care? Now, what if I told you we have evidence, like really good, strong evidence, it's statistically significant that it increases your salary by $1. It's like, I don't know. I don't know what the seminar would be on now. I don't know a good seminar that will increase your salary by $1. And we have strong evidence of this. We've been giving it for 50 years. We have data from tens of thousands of people, and we have evidence it'll increase your salary by $1. You'd say, well, that's nice. It's nice that you have that strong of an understanding. I guess it's due to your large sample size, i.e. strong power. More on that later. But you'd probably say, I really don't want to spend 2 hours of my night to earn $1 extra. Or maybe you'd say, hey, that is practically significant. Every dollar counts. But 2 hours for $1 extra a year, you're not even making it back. Your 2 hours, you might say, I'm just going to hang out with my friends. 2 hours of my time for $1, not worth it. And you're saying it's not practically significant. That's the idea of practical significance right there, is when you say, I don't care about it. So to contrast that, when you do care about it, it is practically significant. When you don't care about it, it's not practically significant. Now we get into some big stuff right here. And actually, I have an idea for this. We're talking about type 1, type 2 error. So I need camera 1 to zoom in on me here. Let me go to the cameras right here. Okay, you ready? Let me make sure I have my audio when I go over to this. Okay. Do I have audio? I do have audio. Audio here? Oh, wait. Give it like 2 seconds. I need to bring the audio over to the other one. Go Excel. I don't have the right camera. That's a bummer. You know what we're going to do? We're going to do the following. Do something live right here. 2 seconds, everybody. Here we go. That's what I wanted to do. Let's just get a background right here. Okay, here we go. So with this, I want you to take a look right here. This is type 1, type 2 error. Right here, I'm holding up a 1. This is type 1 error. And we're only going to be talking about the null. Only talk about the null. This is how to memorize the type 1, type 2 error, and I've seen people doing this during the test. We're only going to talk about the null. Don't talk about the alternative. We're just going to talk about the null. So let's talk about the type 1, type 2 error. Type 1 error, that's what I'm talking about. Type 1 error. In a type 1 error, the null is this. In a type 1 error, the null is this. So what does this mean? What is Brian making right here? I've seen people do this during a test. I've looked around when we give it in auditoriums. I look and I see people like doing like this and like this. We'll talk more about that second part. But in a type 1 error, the null is true. So if the null is true, like think about this, like we go to a court case and we have the null is innocent. It is true that someone is innocent. Like that's what we mean when we say the null is true. The null being true means it is true you are innocent. So this would be true in a type 1 error. That's the T right there that we're making. So in a type 1, the null is true, but what is the wrong mistake we're going to make? We reject it. So let's do this right here. Type 1 error. In a type 1 error, the null is true, but we reject it. So what does that mean? We say guilty. So in a type 1 error, the null is true. This person is innocent, but we reject it and we say we have evidence of guilt. You always have to look at the null hypothesis. So make sure you look at your null and say, okay, the null is that they are innocent. So that is true. They are innocent. That is a true statement. But I'm going to reject that and I'm going to say that they are guilty. To contrast this, and we'll do some examples here in a moment, a type 2 error is when the null is false and we fail to reject it. So we have a person, so we say innocent. Let's talk about what this means right here. I'm going to run out of room. So we say that they are innocent right here. So in a type 2 error, so there's the 2, in a type 2 error, the null is false. Do you see the F right there? In a type 2 error, the null is false, and we fail to reject it. That's the second one right there. So look at these Fs right here that you're making by saying in a type 2 error, the null is false, and we fail to reject it. In a type 2 error, the null is false, and we fail to reject it. So if the null is that they are innocent, that is a false statement. This is a guilty person. But we fail to reject it, which means we don't reject it. We're going to say they're innocent. So in this instance right here, a person who is guilty, because it's false that they're innocent, would be continued to believe to be innocent. So we're going to have a person who's guilty go free. Let's go ahead and think about this and do another example right here. Gonna need to shrink back down. There we go. Hopefully I go to the right side there. There we go. That seems about right. There we go. Perfect. Let's do a few more examples right here and see if we understand how to do this. Let's do some classic stuff right here where we like to do the null hypothesis is going to be a company believes, let's do a classic one, that the true proportion of their customers who use their online checkout services is equal to 20%, and they want to see if they should invest more, so they're looking for evidence that the true proportion of customers who use their online web portal is greater than 20%. So on a test, this could read the following. A company is researching what percent of their clients use the online web portal. This is a large expense, and they are looking to keep it if more than 20% use the portal. They send a survey to, we'll decrease font size here. They send a survey to 500 of their 50,000 customers. That's 1%. That's less than 10%. So we pass the condition for that. Then we'll put right here this question. What is a type 1 error in this context? Okay, left room for myself. Almost perfect. So what is a type 1 error in this context right here? So in a type 1, the null is true. And so what would it mean to have a type 1 error? In a type 1, the null is true. So it is true that 20% of their customers use the online portal. So that is a true statement. So always remember in a type 1, the null is true. So let's go ahead and mark that as true. I'm just going to put a T next to this. And then, but what are we going to do? We're going to reject that. In a type 1, the null is true. It is true that 20% use it. But we're going to reject that and say we have evidence that more than 20%. Remember, in a type 1, the null is true, and we reject the null because we make an error. So we are going to believe that more than 20% of people are using the online portal. And with this, we're probably going to invest more in online because this is not true right there. It is true that 20% use it. We don't have more than 20% using it. So this will probably cause the company to invest more in their online presence when it's not actually being utilized to the amount they want. But what is a type 2 error? So remember, in a type 2 error, the null is what? This is where the 2 comes in. The null is false. There's the 2. The null is false. But we fail to reject it, which means we're not going to reject it. So what is true is actually that it's true that more than 20% are using it. So the alternative is true right here. So in this instance, we would believe that the online portal is not being utilized. So think about that. We fail to reject the false null. So we fail to reject the false null. There's the 2 F's of the type 2. And in this instance, we would say, well, it looks like people aren't really utilizing the online portal. And so we would have right here that we are going to not invest in the online. So in the type 1 error, let's make sure, my brain's like, sometimes I'm like, it's so easy to reverse these. In a type 2, the null is false and we fail to reject it. So the error we make right here, we are going to fail to reject this, but it's a false statement. So it is true that more than 20% are utilizing it. So we should be investing more, but we don't. And in the type 1, like I'm reviewing the tape in my head, I just want to make sure I said the type 1 properly. In the type 1, the null is true and we reject it. So in the type 1, we start investing in the online stuff when we shouldn't, because we believe that more people are using it when the null is actually true. So it's a little bit tricky. Probably one of my favorite examples is the classic kind of cheating example right here, where we have the null hypothesis. And this one doesn't use statistical notation, but it's just a classic example right here. The null hypothesis is going to be that student is not cheating. And the alternative hypothesis is going to be that the student is cheating. And what would a type 1 and type 2 error be right here? In a type 1 error, the null is true. So in a type 1 error, the null is true. The student is not cheating. But we're going to reject that and say we have evidence they are cheating. Just look at the null and say it is true they are not cheating. That's the way to do the type 1 error. Look at the null and say it is true that they are not cheating. Well, we're going to reject that because we're making an error, and we're going to say we have evidence that they are cheating, and that's a big error right there. Like that is to accuse a student of not cheating, to accuse a student of cheating who was not cheating. In a type 2 error, the null is false. So it is false that they are not cheating. They are actually cheating, but we are going to fail to reject that, and we're going to continue to believe that they are not cheating. So this is when someone would get away with cheating right here in a type 2 error. In a type 2, the null is false, but we fail to reject it. Practicing with this, lots of good Mike Pearson examples on it, with the bank example, I believe, and also the court example. But practice, practice, practice type 1, type 2 error. Good stuff right there. And we should know that your alpha right here is your type 1 error rate, and your beta right here is your type 2 error rate. Just think 1, 2, A, B. So you count 1, 2. And you do the letters of the alphabet, and you get A and B. 1, alpha, 2, beta. So beta is the type 2 error rate. Severity of type of error is context of the problem. So you think about type 1, type 2 error rate, it depends. If you have a startup company, then it'd be really bad to make investments where you shouldn't. Where if you have a company that maybe wants to take risk, that's not risk adverse, then maybe they wouldn't be so afraid of these type 1 errors where they reject the null and they say, let's do this, let's try this out. So risk adverse companies, if we talk about business analytics right here, would probably want to make less type 1 errors because they're going to be saying they have evidence of things when they don't. They'd want more evidence. So it really depends on the context of the problem. It depends on who we're talking about. And so type 1, type 2 error, which one's worse? It's just context. So we've asked questions like that on the test, like which is worse, type 1 or type 2? Really just depends on who is making the error, which one they want to avoid. The 3 things that affect beta. Let's talk about beta right here, which is a type 2 error. Okay, so we have 3 things that affect beta. The 3 things that affect beta are going to be the sample size, is going to be alpha, and it's going to be the effect size. And the way in which these all affect beta, so as you increase all of these right here, so if you take any of these, and we'll talk about what they are in a moment, if you increase any of these, by increasing any one of these, oh my gosh, then you will decrease beta. Sure. So as you increase all of these, beta is a type 2 error, then beta goes down. Alpha is the type 1 error rate. Your rejection criteria is the type 1 error rate. So what is sample size and what is effect size? I think sample size is easy enough to understand. That's how many observations we take. So if we take more observations, we have less chance to make a type 2 error. If we increase our type 1 error rate, which is how much we reject the null, we will fail to reject the null less when it's false. Just think about this. When you increase your type 1 error rate, you're rejecting the null more. A type 2 error is failing to reject the false null, so they are inversely related. If you reject more, you'll make less type 2 errors. Now, it's not a good thing to reject more. It just guards against making type 2 errors, so you have to have a balance between the two. Effect size, I think, is the confusing one, but I like to do an example right here, where I play basketball against my brother. So there's me and my brother. He might be a tiny bit taller than me. Or I play basketball, me versus my friend LeBron over here. So there's LeBron right there. There's Brian. And when we think about the effect size right here, Brian versus Darren is going to be a small effect size, like a small observed difference. And this is going to be a large effect size. Now, what effect size is the true difference between the null and the truth. What I mean by this is, if we assume Brian and LeBron have no difference, well, that's preposterous. Of course, he's going to just destroy me in basketball. But the true difference is that LeBron is like 50 times better. Where the true difference between Brian and Darren, if we assume no difference, the true difference is that Darren's a good bit better. He's a good bit better, not as much better as LeBron is than Brian. But when we talk about the effect size right here, the effect size is something we oftentimes have to estimate. So we don't know the true difference between LeBron and Brian, but it'd be pretty easy to see when they play basketball. And that's going to make it easier to reject the null and not make a type 2 error. A type 2 error in this instance would say someone who believes LeBron and Brian are the same. It's much more likely to make a type 2 error here and believe that Brian and Darren are the same because the effect size is smaller. Like you could watch Brian and Darren for 20 minutes and watch LeBron and Brian for 20 minutes, but because of the larger effect size here, same sample size, it'd be easier to reject the null and not make a type 2 error when watching LeBron and Brian play basketball because there's a large effect size, a large true difference between the null and the truth. So that's what the effect size is. It's like, well, how much is this actually impacting it? And when there's a large impact, like a true impact of something, then it'd be easier to see. And by easier to see, it'd be easier to reject the false null, which is what we should do. Type 2 errors when we fail to reject the false null. And where is this all leading to? Because it's going to all come right back around. So we have here the trade-offs between alpha and beta, decreasing the probability. So we talked about these. That's just literally that. Sample size, yep. And then we have here power. And that's what I have over here. I left room for right here. Because when we increase alpha, it decreases beta. When we increase sample size, it decreases beta. When we increase effect size, or when there's a larger effect size, we don't really control effect size. It's just what exists in the data. We have a smaller beta. But with all this right here, power, we'll do it in a different color, is 1 minus beta. Power, known as, and this is a good definition to write down, the ability to reject the false null hypothesis. The ability to reject the false null hypothesis. So the probability of us rejecting the false null hypothesis is power. It's basically not making a type 2 error. So if you notice right here, power is the complement of beta. So when we have beta right here, beta is making a type 2 error. Power is the ability to reject the false null hypothesis. So if the null hypothesis is false, we shouldn't make a type 2 error right here. So all of these right here, if you increase sample size, you increase power. If you increase your alpha, you're rejecting more, and hence you would make fewer type 2 errors, and you'd have a stronger power. When there is a larger effect size, we don't really control effect size. I don't control how much better LeBron is than Brian. But when we have a larger effect size right here, we have more power. It's easier to reject the false null hypothesis. And I think that does it. We're back on schedule now. So we're able to do this one a little bit quicker. I think that covers all the topics for this. Stay tuned, everybody. More speedruns to come. We're getting these done. We got this. See everyone later. I'll be back in a bit. Bye.